Hello everyone. I really missed each and every one of you. I hope that everybody is safe with their families. I hope that you wash your hands a lot, and I hope that you don't go out unless it's something necessary. Um, I know there's a lot of questions and inquiries. Maybe some people are panicking, maybe others are happy that we don't need to go to classes. But of course, everybody is questioning, and we are not sure of the current situation. But let me assure you that we professors are doing our best to deliver you the best education ever we can at the time being, given the circumstancing that we are experiencing. For many of us, the professors, this is the first time where we convert to online teaching. Some people did it during the Saura. It was in a certain summer where they converted to online education, but for me, this is the first, and for many others. This is what we call a force majeure circumstances. We were not expecting it, but we are experiencing it right now, and we are doing our best to deliver you the best education. From your stance, you need to do your best also to study on your own. You need to do your homeworks, Googling, studying, looking for other sources, maybe emailing your professors, giving feedback to us whether the I call it experiment, whether the experiment is worth it or not, how we can enhance it, if there's any other tools that you would prefer that we use. So it's mutual, we're doing our best, but on the other hand, you also need to do some work from your behalf. I am trying using this tool, which is PowerPoint with video. There's other tools that I can incorporate later. I was also thinking of conferencing, but this has to be with a minimum number of students. Maybe the maximum number would be 10 students. But I was thinking of doing it maybe on solving the homework on WebAssign, or if someone have questions in a certain lecture and he needs to talk to me face to face. Okay. If you have any questions, you can just email me. But what I'm gonna do is I'm gonna post a lecture on the day that we were supposed to meet. You will find one lecture on Sunday and another lecture on Wednesday. The homework web assign is postponed, and I'll post you the new dates for it. Regarding quizzes or exams, we have no information regarding them. We still do not know how we can make the quizzes or exam. We are not sure of it, whether it will be something online or it will be another kind of assessment. This is still not confirmed. Anyways, let's just start our lecture. We are now starting lecture 11, which is the derivatives of the trigonometric functions. Before I start the lecture, let me also tell you that the last slide, you will find a link to a YouTube video performed by another professor, which is really good. And if there is any part that you miss or you think you do not understand, you can go back to this lecture and you can check the lecture. He's really good. Or you can check other YouTube videos regarding the same topic. Okay, so let me remind you of what we have taken, because it's been 1 week off and I'm sure what's going on made you maybe forget what we're doing. So we said that the math is all about the derivative. Up till midterm 1, we were talking about the limits and their functions. And then we started lecture 9, where we introduced that we can use the limit equation to find the derivative or the slope of a function. And then last class, we took the rules to perform any differentiation or to find the derivative of any function. Right now, in this lecture, we will discuss the derivative of the trigonometric functions. So right now, if you look at the sine function, which is this red function, which you already know, and if we look at the blue function, which is the cosine function. Okay, if you trace the points and if you trace the slope at each point, you will find that there is actually a relationship between the sine function and the cosine function. The relationship is that if you trace the sine function and find the slope at different points, you will find that this is exactly what the cosine function is. So right here, if you look here, and what is the slope at pi over 2? If you draw a tangent line at this point, you will find that it's horizontal, which means that the slope at this point is 0. If you just go down at the same point to the blue function, which is the cosine, you will find it equal to 0. Alright? Okay, let's take this part. This part, the function is decreasing, so the slope has to be negative. If you trace the function of the blue one, you will find that all the values in the same decreasing sine function will here have a negative value. So what is meant by this slide is that if you follow the sine function and you follow the slope of the sine function at each point, this will exactly be equal to the cosine function. And this means that the derivative of sine x is cosine x. This is the same of what I have just said in the last slide. I'm talking about the different slopes of the function. Here the slope horizontal, you will find here that it's 0. Here the slope is decreasing, you will find that the values of the function here is negative. And here if the function is increasing, you will find that the slope is positive values. So if this is the sine function, the derivative or the slope of it is cosine x. Alright. The previous two slides were the geometric proof. How about the algebraic proof? I want to prove that the derivative of sine x is cosine x. So this is the proof. You can read it. I'll just follow it very quickly. So we use the derivative equation. Do you remember the derivative equation? The derivative equation, we had two formats of it. This is one of them, and we said we can use it to find the slope or the derivative of any function. It's the limit where h approaching 0, f of x plus h minus f of x over h. Okay, f of x is the original function sine x. So let's go to step number 1. He made sine, instead of x, he wrote x plus h minus sine x over h. Step number 2. He expanded sine x plus h. Do you remember? We had a certain expansion, one of the identities that we took in trigonometric functions. So here it is. He expanded it, and then you still have minus sine x over h. Let's go to step 3. Step 3, he started taking common factors. So he took the sine x as a common factor and rearranged the terms. Step number 4, he divided the terms on the h. Step number 5, we reach this one, this format. So it's all rearranging the terms, all right? And then we found that we have sine h over h. The limit of sine x over x, we took it before in lecture 6, and we tried to find the limit for it, and we found that's equal to 1. All right? And this is one of the trigonometric formats that I want you always to remember, that the limit of the sine x over x as x approaching 0 is equal to 1. So here again, he just substituted this term in step number 5 with 1. And this term as it is. And we call this equation number 2. And in the next slide, we're going to try to understand what does this term means or what it is. Again, we are in the same proof that the derivative of sine x is cosine x. So we solved and we just took this term that I was telling you about. I solved it as a limit function. Direct substitution, it gave me 0 over 0, so it's indeterminate. So I thought of using the conjugate. Conjugate, if you remember, I use the same term, but I make the sign different. Negative will be positive, and I multiply up and down. So here in step number 9, I multiplied by the conjugate, and I reached cosine squared minus 1. If I use this identity, one of the identities that we use, cosine square h plus sine square h equal 1. So cosine square h minus 1 will be equal to negative sine square h. Here it is. Alright, and then again I took sine h over h, which will be equal to 1. Alright, and then this one, if you do direct substitution to this term, it's gonna be equal to 0 over 2, which is 0. So the whole term is equal to 0, and this is equation 3. So cosine h minus 1 over h is equal to 0. This is another format I want you to remember, that cosine x minus 1 over x is always equal to 0. Back to equation 2, which was in the previous slide, he started to insert what we found from this format in step number 11, and he resubstituted in equation number 3, and ta-da! Where the derivative of the sine function is cosine function. Okay. Why did I include this proof in my slides. I included this proof in my slides so that you know that. First of all, we can use the limit definition of the derivative, okay, to find the derivative. This is the main idea. This is how we give you formulas. We apply the equation and we find what we found from the equation, and then it became a rule. So this is something I want you to know. The second thing, I want you to know that the limit when x approaches to 0 of sine x over x is equal to 1, because we will use it in other tools and in other applications and examples. And I want you to know that cosine x minus 1 over x is equal to 0. Okay, so I want you to remember these three things. You can always use the limit definition equation to find the derivative. Alright, I want you to remember that sine x over x, or the limit of sine x over x, is equal to 1. And I want you to remember that the limit of cosine x minus 1 over x is equal to 0. Alright. We did the same limit definition equation to all of the other functions, and we already now have the rules that we can use directly without needing to use the proof or anything. Sine x will be cosine x. Cosine x is negative sine x. Tan x is sec square x. The derivative of cosec x is minus cosec x cotan x. Sec x is sec x tan x, and cotan x is minus cosec square x. You need to memorize these 6 derivatives of trigonometric functions. Okay, example. Find the derivative of the following functions. F of x equal x sine x plus cosine x. Alright, I want you now to have a paper and a pencil, alright, and I want you to attempt to solve it on your own. X sine x plus cosine x. Alright, we know what is the derivative of sine x and we know what is the derivative of cosine x, right? But be careful. The first term is actually not one term. It's actually composed of 2. It's x times sine x. So right here you need to use the product formula. Remember it? It's first derivative second plus second derivative first. And then plus the derivative of the cosine. Alright? Check what you have done. The answer is in the next slide. B. I have a function divided by another function. So which rule should I use to do the derivative? This is the quotient rule. So it's down squared. Alright? And then on the numerator it's going to be down derivative up minus up derivative down. So try to do it yourself. Alright? Right here I gave you the link to a site that you can use to check any derivative of any problem that you have. You just write the function and it will give you the derivative with its steps. Okay? I do not encourage you to use it to solve the homework, but I encourage you to use it to check your answers. Because once you solve and then you find that you are wrong, this will help you to trace your mistake. What did you forget to do? So you can use it. It will make life much easier. It will be easy for you to check your answer. It gives you steps. So I hope you use it rationally. Here come the rules. If you forgot any of the rules, I have it here at the top of the slide that you can use. This is the answers. Alright. Here, I'm giving you the formulas that were used in the proof, and I told you that I need you to remember. Alright? So, the first one, whenever you found a limit problem when x approaching 0, and you have sine x over x, this term as it is, you can just cancel it and write equals 1. Okay? And it's not just sine x over x. It is sine any term, any constant beside the x, over the same term. So it could be 5x over 5x. It could be sine 7x over 7x. It could be sine 2 pi x over 2 pi x. What's important that what's beside the sign up is down. This is equal to 1. The second format is that the limit as x approaches 0, cosine x minus 1 over x equals 0. This x could be anything. It could be cosine 5x, but here should be 5x as well. It could be cosine 2 pi x, but here it's 2 pi x as well. So what's important that what's beside the cosine is the same as the denominator, and the whole formula is equal to 0. The tan is just like the sine, tan x over x equals 1. All right, so if we have any derivative problem or if we have any limit problem with trigonometric functions, we will do our best to try to reach this one so that we can use their end results. Let's take example. Try to solve these 4 examples. All right, now try to solve them on your own. It tells you evaluate the following limits. So you need to find the limit of the following functions. The first one, limit when x approaching 0 is sine 7x over tan 4x. Could this one reach the formula that I told you about? I told you that if I have sine x over x is equal to 0, if I have tan x over x is equal to 0. But what about sine 7x? I need to make it reach what? Sine 7x over 7x. What about tan 4x? I need to make it tan 4x over 4x. How can you do this? Can you do this? Can you introduce new terms to your equation? Yes, you can. But you have a condition. If you multiply something up, you need to multiply it down. So if you are going to multiply the sine 7x, okay, you want to divide it by 7x, right? You need to apply the same to the denominator. And the tan 4x, if you're going to divide it by 4x, you need to do that to the numerator as well. So try to figure it out. If you are stuck, the answers is in the next slide. Alright, what about this one? When you find 2 terms up and 1 down, one of the things that you can do is to distribute or divide the terms. So this is the same as 2x over x minus tan 3x over x, right? And then this tan 3x, you want it to be what? Tan 3x over 3x to say that's equal to 1. So think how you can reach that. C. You have x cubed over tan cubed 2x. Alright. Can I just make it x over tan 2x all cubed? Yes, you can. Because we have the same power up and down. And then this tan 2x, what do you want it to reach at the end? You want to make it tan 2x over 2x. So that you can say it's equal to 1. But if you're going to do something to the denominator, you need to do it to the numerator as well. So check this one out. And then we have this one. Alright? Don't forget that you can still use conjugates. You can still use the same methods of simplification that we used to do the limit. Alright? Try to solve these 4. If you are stuck, check that. Okay, let's check the answers. The first problem, it said limit as x approaches 0 sine 7x over tan 4x. Okay? Alright. Ask yourself, what do you want to reach? Well, I want to reach sine 7x over 7x because this means it's equal to 1. And I want this denominator to be tan 4x over 4x. How to do this? What I'm going to do is do some multiplications and division to reach the format. So right now I'm reaching with the upper term, sine 7x. Alright? What did I do? I want it to be sine 7x over x. So I divided the upper term by x, but I need to do what? To divide the lower term with x as well. But this is good because right now the tan 4x became divided by x. And this is one of the things that I want. Check here. This is one of the things that I want. Alright. What else? Well, I need this 7x. So I need here to multiply by 7. Because I want it to be sine 7x over 7x. Because this is the formula. Sine anything divided by the same thing is equal to 1. So what I'm going to do is I'm going to multiply this x with 7, but I need also to multiply the upper one with 7, so that at the end, 7 divided by 7 is 1, and the equation is the same, right? So this was going to be 7 sine 7x over 7x. If you just cancel the 7 with the 7, you're back to the original one. So this means you are correct. What about the denominator? It became tan 4x over x. Alright, I want this to be 4x, so I will multiply by 4, but don't forget, if you multiply something in the denominator by 4, you need to multiply the upper one as well. So I multiplied up and down by 4, so it became 4 tan 4x over 4x. This sine 7x over 7x is 1, so it's equals 7 times 1. And this tan 4x by 4x is 1, so it's 4 times 1, so the answer is 7 by 4. Okay? So the idea is whenever you find a limit and any trigonometric function, you will try to reach the given formulas by multiplying and dividing. But don't forget, if you multiply something up, you need to multiply it down, so that at the end, the equation is the same. Let's check the second problem. This is it. Limit x approaches 0, 2x minus tan 3x over x. So one of the things I can do is to divide the terms. So I made it 2x over x minus tan 3x over x. 2x over x, I can just cancel the two x's and it will become 2. What about tan 3x over x? What do I want it to reach? If you think about the formula, it's tan 3x over 3x. So I need here a 3. So if you multiply here at 3, what you need to do upwards, multiply by 3. So it became 3 tan 3x over 3x. Alright? So tan 3x over 3x, this term will be equal to 1. So it's 3 times 1, and at the end it's equal to negative 1. Alright? Okay. Third problem, limit x approaches 0, x cubed over tan cubed 2x equal to x cubed over tan 2x all cubed. This is the same. This cubic power, I just put it outside and I made my brackets the same. And then, because here it's cube and here it's cube, I can just write the whole term and leave the cube up. And right now I'm dealing with x over tan 3x or 2x. Sorry, x over tan 2x. So tan 2x over 2x, if I reach this one, is equal to 1. But what if I flip the numerator and denominator? Still will be equal to 1. So if I just reach 2x over tan 2x, I can just say it's equal to 1. This is x over tan 2x. I want it to be at 2x over tan 2x. So I need to multiply what? 2. Do I just multiply here 2 and leave the denominator? No, I need to multiply up and down by 2. So here it is, up and down by 2. And then I take all this term and I say that this term is equal to 1. So what I am left with, I'm left with 1 over 2 cubed, which is 1 over 8. Fourth example, x sine x over 1 minus cosine x. I started to make it sine x over x, and I also attempted to make it 1 minus cosine x over x, but at the end I was always left with 0 over 0, which means indeterminate. So the last thing that I thought of using is a conjugate. So I thought, why not to use a conjugate of this 1 minus cosine x. This is what I did. I used the conjugate, same term, changed the sign. Negative became positive. And then I did the multiplication. So it's x sine x times 1 plus cosine x over 1 minus cosine square x. This one is one of the identities. I can use it. 1 minus cosine square x is sine square x. So it became x sine x 1 plus cosine x over sine square x. I can cancel sine x with the square. And it's right now like this. And I know that the limit when x approaches 0 of sine x over x, or the limit as x approaches 0 of x over sine x flipped, will be equal to 1. So I'm left with 1 times 1 plus cosine x. Last step, substitute x equals 0. So it's gonna be 1 plus 1, and it's equal to 2. Alright. What else can we do to find the derivative or the limit of trigonometric functions? In many problems, it's very hard to find the limit value or the value of the derivative. And what we do is we try to match the problem to the format of the limit definition equation. Do you remember them? The limit definition equation. We had two formats. This is one of them. The limit when x approaches a, f of x minus f of a over x minus a. If I just prove that the given equation resembles this one, okay, I will say this one matched that one. And if I just can know the function f of x, I will use the rules to find the derivative. So if this f of x is sine x, then the derivative will be what? Cosine x, right? So what I need to do is to relate the given equation to the limit definition equation, and then I get out the function and I just use the rules to find the derivative and say that this is the value of the limit of this function. Alright, so the function given is the limit when x approaches pi tan x over x minus pi. Alright, does this one match this equation? Let's check. X, here we have x. Minus pi, here minus a. So most probably, what does this mean? A is pi, right? So let's check this one. X approaching pi, x approaching a. Yes, so from this, I can understand that if I prove that this one is equal to that one, the a is the pi. All right, let's look at upward function, tan x. If this tan x is f of x minus f of a, well, I'm not sure, because here I have two terms, and here I have only one term. But what if this term is equal to 0? Well, if I prove that f of a of this function is equal to 0, then I think this function matches this one, because here it's x minus a, x minus pi. If this is f of x minus f of a is 0, so we are left with f of x over x minus a, the same as this one. So how to prove this? Let's try to do it. So I know that a is equals to pi. I knew this from here and here. And if f of x is equal to tan x, alright, let's substitute and find f of a. What is f of a, which is f of pi? Tan pi is 0. So this term is 0. So actually, this function is just like this whole function. It's the same, right? So I will just take the function f of x, which is tan x, right? This is what I used in the proof. It's tan x. So what is the derivative of tan x? Sec square x. And then I do direct substitution, sec square pi, and I write the answer. Alright? So what I'm trying to do whenever I find something like this, that I cannot solve it by any method that I took before, like here, you can try to find tan x over x equal 1. Most probably will not work. You can try direct substitution. It will give you 0 over 0. So the last thing you will do is try to match it to the limit definition of derivative equation. Alright, how you prove it? You find a, you find the function, you prove that f of a is the same as the second term in here, which here was 0, and then you just use the rules that we have taken to find the derivative. Alright, let's try to do these. Do it on your own. Try to solve it on your own. Alright? This is the first one we did before. Tan x over x minus pi. Let's start with the second one. Here we don't have x approaching a number like here or there. We have h approaching 0. So which format are you trying to use? This is the one that says that the limit as h approaches 0 equal f of x plus h minus f of x over h. So you will try to prove that this is f of x plus h. And you will try to prove that this is f of x. Alright? And then you will find the function and then use the rules that we have taken to find the derivative. Let's look at this one. Sine x minus 1 over x minus pi over 2, x approaching a. Most probably a is pi over 2. Alright? Most probably this is f of x. If you prove that f of a equal 1, then if this is sine x, so what is the derivative of sine x? It's cosine x. So it's cosine pi over 2. Let's check what I have done. This is the first one. I will not go through it again. Second one, sec 2 pi plus h minus 1 over h. I will try to match it with this limit definition. Okay. X plus h, 2 pi plus h. So what is x? 2 pi. Right? So if this is f of x plus h, what is just f of x? F of x will be sec x. Right? So f of x is sec 2 pi, which is equal to 1. Check here, 1. So the equation f of 2 pi plus h minus 1 over h equal the given equation. It's equal to the derivative equation. So the function is sec x. What is the derivative? Sec x tan x, and then direct substitute x equals 2 pi and find the answer. C, limit x approaching pi over 2. First thing, a equal pi over 2, right? F of x, here it is, sine x. F of a, sine pi over 2 equal 1, same as this one, so therefore we match. If this is the function, sine x, so what is the derivative? Cosine x. Last step, direct substitute x equals pi over 2. Okay? Let's move. We are done. All right. This is the source of one of other lectures done by a professor in the US, and he is really good. He's also talking about what we have discussed. It's on YouTube. He's using the board, so maybe it will be easier for you to follow. Please give me a feedback. Was it clear? Was it not clear? Do you like the video with the PowerPoint or not? Do you just want the PowerPoint? You will also find them in the class links, in the old ones. And please give me any feedback and stay safe. Don't go out unless it is something necessary. Wash your hands as much as you can, and it's actually all about your parents. It's all about the safety of your parents, because for your age and my age, they said it's a little bit safe. But the problem is that we can carry it and move it to our elderly people. So may God bless us and bless Egypt, and hopefully I will see you all soon.